Good day, everyone. I am Grim GB Cadorna, a second-year mechanical engineering student at Capitol University. Now, we need to solve this type of problem. Now, let me start. The formula of a capacitor is equals to Q is equals to CV. We need to rewrite it because due to the finding of our problem, V is equals to Q over C. Now, we need to solve for problem number 1. First, C is equals to epsilon sub-0 A over D. So, this is the given. Epsilon is equals to 8.85 times 10 over 12 F over meters. Now, for A means area. So, area is equals to 2 centimeters squared equals to 2x 10 per negative power of 4 meters squared. Now, for distance. Distance is equals to 2 millimeters is equals to 2x 10 to the negative 3 power meters. Now, we need to solve for C, which is this one, for problem number 1. C is equals to substitute the given, which is, this is our formula, this is our given. We need to substitute it. Now, we need to solve for C. So, C is equals to, according to the formula, epsilon, which is this one, our given, close parenthesis 8.85 times 10 to the negative 12 power, times, open parenthesis, our area, which is 2.10 to the negative 4 power, over 2x to the negative 3 power, which is our distance. Calculate it so we can get 8.85 times 10 to the negative 13 power F. This is our C. This is our C. Now, we need to find the voltage. So, for problem number 1, voltage is equals to Q over C, which is given by this formula. Now, we need to we need to substitute it by the given formula from our problem, which is equals to 4 times 10 to the negative 12 power over C, which is this one, 8.85 times 10 to the negative 13 power. So, the total is 4.52 volts. This is our voltage for problem number 1. So, next, for our problem number 2, find our turns for the solenoid. Let me erase this first. Now, for our problem number 2, we need to find the turns on our solenoid, which is the formula for the inductance is equals to mu sub-0 n squared over area over length. This is length. So, based on the formula, let me just write the given first. So, L is equals to 0.285 megahertz. So, we need to do it like this. 0.285 to the x times 10 to the negative 3 power hertz, henries, So the given is inductance is equals to 0.285 mega henries is equals to rewrite 0.285 times 10 to the negative 3 henries. So sub-0 is equals to 4 pi, because it's a solenoid, 10 negative 7 power henries over meter. That is our mu. Area is equals to 6 times 10 to the negative 4 power meter squared. And for our length, 36 centimeters, we need to convert it to meters. So, 36 divided by 100 meters over centimeters. So, cancel. 36 divided by 100 is equals to 0.36 meters. Now, we need to solve for turns. The formula is N for turns is equals to square root of inductance times L over mu sub 0 times area. If we need it, the phase will be N is equals to square root of inductance, which is 0, or this is 0.285 times 10 to the negative 3 power times 0.36 meters over mu, which is, and this is 4 pi times 10 to the negative 7, close parenthesis, open parenthesis, and our area, which is 6 times 10 to the negative 4 power, close parenthesis. Now we need to calculate the numerator with the other numerator, and the total of that will be square root 1,026 times 10 to the negative 4 power over 7.54 times 10 to the negative 10 power, which is, if you calculate it, the terms will be 368, but we need to round it up, so it will be 369 turns. This is the answer of our problem number 2. Turns is equals to 369 turns. This is unitless, but we need to put turns here so we can know what the number stands for. So let's do problem number 3. Let me erase this. Okay, for problem number 3, we need to find the rate of change of the current. So the formula of the rate of change of a current is equals to EMF is equals to negative inductance, the derivative of current over derivative of time. So we need to find it. We need to find the rate of change, and the formula will change onto di over dt is equals to negative EMF over L. So we need to substitute this formula based on the given, which is di, or derivative of current, di over dt is equals to negative times negative 12.5 times 10 to the negative 3 power over 0.285, times 10 to the negative 3 power. Based on our given, we need to cancel out the times 10 to the negative power because they cancel out. So, and this will be positive, negative times negative is equals to positive, so erase this. So this will be the given of our problem. Now we need to solve it. di, the derivative of a current over dt is equals to, calculate 43.86. So current, this is current, I write A amperes over the time, which is rate of change, meaning seconds. So this is our total for problem 3 based on the given problem. Now, if we need to revise all the total, the answers will be, problem number 1, the answer was voltage of the battery is equals to 4.52 volts. The final answer for our problem 1 is the voltage of the battery is equals to 4.2 volts, and for the problem number 2, the number of turns in a solenoid is equals to 369 turns, and for problem number 3 is equals to the rate of change of current is equals to 43.86 amperes per second. This is the total answers of the given problem. Okay, we are done with the topic. I hope you enjoyed it. I hope you listened to it. And if you have any questions, just review the video or pause the video to understand the process. If you have any questions, just ask in the comment section below. So, this is the end of our video. I am Jimmy Cadorna, a second year mechanical engineering student at Capitol University.